class. We are on 18.5 and we're doing part 2. Yay. All right, so part 2, you're going to notice with the triangles and on the left side here, it says finding angle measures. So in our part 1, we were finding x, which was a side length, the side measure of a triangle. Now x is in the degree spot, so it's a degree. All right, so it's going to be a little bit different now that we're finding angle measures, but there is a lot of the same. So the first 3 steps are the same, and then the only thing that's different is even better. You don't have to solve. And for the first thing, and for the second thing, you just use it in the calculator without any extra steps. You just go straight to the calculator after you figured out the trig function. You just throw it into the calculator and you're done. So it's pretty nice. Now, if you know the sine, cosine, or tangent ratios of any angles, then you can use the inverse ratio, sine inverse, cosine inverse, or tan inverse to find the measure of the angle, which is kind of crazy because I'm going to show you, maybe if it doesn't move it, I hope it doesn't move it. So if I have sine, it so moved it. If I have sine theta is opposite over hypotenuse, which it moved on me. So it's going to be kind of hard, but I'm going to try to figure out where to write it in order to have it be seen. So if sine theta is opposite over hypotenuse, then what happens is if I take sine inverse, remember the inverse functions of opposite over hypotenuse, then that is equal to the angle theta, which, let's see, sine inverse opposite over hypotenuse equals theta. It's just jamming it all up there. That's so dumb. Maybe I'll write it right here. So with sine inverse, see that little -1? That's not an exponent. It's not that. It's inverse function. Remember y inverse, what we did for that, or f inverse of x? What we did is if we had y equals x minus 1, we would take the inverse, we would switch it, x equals y minus 1, and then add 1, solve for y, and we'd have it's equal to x plus 1. F inverse of x is equal to x plus 1, and that would be our y inverse. What we're going to do now is we do the same thing. If I have sine theta is opposite over hypotenuse, now these are trig functions. They're non-transcendental, so they don't follow the actual rules of algebra, but they do follow the fact that if it's an inverse, you switch. So if you switch, in this case, we have to switch the angle with the ratio. So it would be sine O over H, and that's where we put the inverse. Remember how we have to add the inverse in the end? And that's equal to the angle. So that's a pretty cool thing, actually. It's a way to come up with an angle. So our angle is equal to the sine inverse of O over H. And that's, again, just switching the ratio with the angle, just like we switched before the O and the H, or the Y and the X. So what happens is we have sine inverse of O over H. We have cosine inverse of A over H, and we have tan inverse of O over A are all equal to our angles theta. So if I can find a ratio of 2 sides, then I can figure out which sides I have. Do I have an hypotenuse? Do I have an opposite? Do I have an adjacent? Which sides do I have? And then I can use my inverse functions, and with those inverse functions, I can come up with the angle theta. Now, inverse functions are just secondary functions on your calculator. They're pretty cool because, again, the ratios are pre-programmed into your calculator, and it knows what the ratio is for the angle, and your inverse function is going to find that angle for you. It's like magic. It's so awesome. So, like I can show you right here, if you look in this calculator and I turn it on, if I know the ratio of sides is 1 to 2, I can see sine, see the sine, cosine, and tangent here, and you have sine inverse, cosine inverse, and tangent inverse above. See the little inverse functions? So that's pretty cool. I mean, that's really awesome. If I clear this all out, I hit second sine, then that's going to tell me, if I can plug in the angle, say 1 over 2, sorry, that's the ratio of sides. If the sides are 1 to 2 for a sine inverse, I can hit enter and it's going to tell me, oh, that has to be a 30-degree angle. So that's what theta is equal to. I can do the same thing for cosine. So second cosine, 1 divided 2, and that's going to give me a 60-degree angle. Those are special angles. I already knew the ratios. All right, and then tangent. Can tangent be 1 over 2? Yeah, it can. Second tangent, 1 divided 2. And that's going to tell me the angle for a 1 over 2 ratio for the opposite over adjacent. And it is 27 degrees approximately. All right, for that angle. Pretty cool. All right, let's move this out of the way and we'll do a few problems. All right, so example 1 says, if you know the sine, example 1 doesn't give us any instructions, but we are trying to find that angle right there, which is x degrees. All right, so what we do, again, we label the sides. Same thing as before, label sides. So this is opposite and this is adjacent. Once we've labeled the sides, we figure out which of the functions, just like before, that is a ratio of sides for. And it's opposite or adjacent, so that's the tangent. Okay? Now, because we're dealing with an angle, we have to use our inverse function. So instead of writing the angle measure, we write inverse, and then we write the ratio of the two sides opposite to the adjacent, just like the tangent requires. That's 10 over 19. So tan inverse of 10 over 19 is 27.8 degrees. Now, usually in degree angles, we just round to the nearest degree. This is a decimal behind it, becomes degrees, minutes, seconds, and it's a little more challenging as to what that decimal is. So it's just better to round to the nearest degree, 28 degrees. All right? So it's nice because you figure out the O, A's, and H's, you label the sides, you figure out the function, the trig function that we're using, and then you just put in the ratio, put in the inverse and the ratio sides, and you're done. Throw it in the calculator. No solving step, which is so much easier. All right, so this is degrees right there. This side is a hypotenuse. This side runs right into it. It's one of the legs that runs into it, so it's A. So adjacent hypotenuse, we're going to do cosine, right? Cosine is adjacent over hypotenuse, so this time we're going to use the inverse because we're looking for the angle. Adjacent is 31, hypotenuse is 36. So in our calculator, 31 divided 36, I'm going to try to put this over here. We'll do second cosine, which gives us cosine inverse, 31 divided 36. And that's 30.6. 30.6 degrees, or 31 degrees if we want to be on the angles. All right, now again, if you're not getting that and you plugged in the calculator just like I did, then the only thing that I'm guessing is wrong on yours is the degrees. So you have to go into mode and make sure your degree is highlighted. Okay, if radian's highlighted, you're going to get the total wrong answer. So we need to make sure degrees are highlighted. All right, and then once you do that, then you can do second cosine, put in your 31 divided 36 and hit enter, and you should get that 30.558. All right, so moving on over here to example 3. Okay, example 3, this is your angle. Across here is the opposite, and right here runs right into it. It's not the hypotenuse, it's a leg, so it's adjacent. All right, O and A is tangent, opposite divided by adjacent. So we're going to do tan inverse of opposite, 25 divided by adjacent, 78. All right, so I'm not going to bother with showing you. You can plug it in your calculator. 25 divided 78 after you've hit second tan, 17.8 degrees, or 18 degrees if we want to be more specific. All right, now the next one's going to combine both, which is cool. We can combine both. That's no big deal. Trying to figure out how much. All right, I just want to make sure I don't go over the 15 minutes. Okay, so here we have Wow, that's kind of crazy. I got all new colors here. How cool is that? I don't know why. But anyway, this is our side that's between them. Now, what we're asked to find is the measure of angle W. That's kind of thick. Let's do that one. Okay, so we want the measure of angle W. So if we want the measure of angle W, then what we can do is find this side because it's the side that combines both triangles. Now, if I want W, I need two things so that I have two of the variables fulfilled. I know their numbers, and then I can find the third variable. But in this case, I don't have a third variable. I have a side, it's 22, and that's all. And I have an angle that I want to find, but I don't have another side, which I would need, or another angle. So what I'm going to do is I'm going to come up with this side right here. I'm going to call it X. And if I have this side and this side, that side that's 22 and the side that I labeled X, then I have two sides to compare to find W. So that's what I'm going to do. All right, I have 25 degrees. We're looking just at the right triangle now. I'll highlight it. This is the triangle we're looking at. We know the angle is 25. Right here is 25. We know the opposite side is 15, and we know the hypotenuse is X, which is what we're trying to find. So O and H is sine. So katoa. So sine 25 degrees is equal to our opposite, 15 over hypotenuse X. And then we'll have that information to find angle W's measure. All right, now X is in the denominator. So what do we do when X is in the denominator? Oh, we switcheroo. So we have X equals 15 over sine 25. All right, so 15 divided sine 25 is 35.493. Now, I'm just going to use that in my calculator, but I'll write it down so you guys can see what you've got there. And then we're going to have to come up with a whole new deal. We want this angle. So we're going to label, let's see, we have this side and this side. So this side with our X, or 35.493, is going to be opposite, and the 22 is adjacent, runs right into W. So O and A is tangent, so we're going to do tangent. Now we're looking for the angle W, so tan inverse of the ratio of sides, which is that 35.493 that I'm leaving in my calculator over 22. All right, so how I put that in my calculator, make it the easiest. I already have that right there. So I'm going to do second tan, and then I'm going to go up and highlight and hit enter, and it will put it right there for me, and it's all there. And it'll be my most accurate answer because I have the most numbers after the decimal. And then we're going to divide that 22, which is in my formula. And it is 58.2 degrees. So 58, measure of angle W is 58.2 degrees. All right, and that is the end of 18.5. So you can go ahead and do the homework, and if you need to, re-listen to the videos or whatever. But if you have questions, let me know. Have a good day.